Hope you're doing well today. Here is another rendition of Zephyr 101. And today we're going to be talking about hardware model version 2, at least hopefully touching on it to give you guys a better idea of what's going on there. And then also Sysbuild, which is also very exciting. Taking some of the features that kind of existed in NCS and bringing it to Zephyr as a whole. So that is very cool. And let's just jump into it. If you haven't already subscribed, hit that subscribe button, hit that like. Gives me inspiration to keep going with these videos. So we really appreciate you being here, and let's jump in. I'm gonna make sure just make sure my audio is working. So some big changes. In some cases, some big things, not so much in other ways. So the definitions themselves have not really changed a lot. There's just some new ways to call boards and also ways to define the overall structure of a board. They made it, some of the reasons why they made these changes are primarily because there are more chips that are coming out with multiple processors. They also have, there's chips out there now like the Raspberry Pi, the new ones that have the combination RISC-V and ARM chip, which is also very interesting. So these changes were made so it could be easier for you to create your own boards based on these more complex chips. For instance, now that the Nordic, the Nordic series, NR91, NR53, NR54, they're all multi-core chips. So you need this functionality for it to work to some extent. A lot of it was proprietary to Nordic before, so they've changed over to using Sysbuild, which is fantastic because it kind of lifts up the whole Zephyr ecosystem to some extent. One thing that I've been doing is been testing out a prototype board here, the NF9161 Feather, and originally I had just created the board definition using the version 1, just regular board definitions, and since I wanted to upgrade everything to the latest version of Zephyr, needed to make sure that it was compliant. So here's some of my learnings, some of the things that I've found as I've gone through the process. So hey Eric, thanks for joining. So in an effort to clean up how the boards are defined to some extent, the board structure, if you're familiar with Zephyr, the board structure was previously by architecture. Now it's more by kind of vendor or kind of that prefix and then the name of the board, and it goes further in, and you guys will see that shortly. There's there was like kind of a YAML file, and they still do exist per the different variants, but there's an overarching board.yml that actually basically says, hey, or Zephyr will go and look at it and be like, all right, this is all the information I need to know about this board, if it has variants, if it has versions. So it's handy, and it's kind of like in one place. There's some kconfig values that did get removed, or they're just not used in the same way that they were previously. So there are some like very board specific, like when you want to use a certain board, this variable gets enabled, and it was just kind of redundant. So all that stuff kind of got removed, and it's under the hood now. So you do have access to those variables, but they're not like explicitly set in a default config file. So in the default config files, you used to have like config board name equals yes, and obviously this is not really needed anymore, which is cool. And this is what I was referring to in terms of like the board location. Previously, Circuit Dojo boards or Zephyr boards, ARM, Circuit Dojo, or yeah, Circuit board, Zephyr boards, ARM, and then the name of the board. So Circuit Dojo Feather, NF9160, blah. So it's a little bit different. This is where it is living as of right now. So this is that board.yml that I was referring to. You can see You can see the name of the board, which hasn't really changed. That's actually consistent from the previous one. And the so the vendor that's something kind of new. That's the kind of the folder name. And then you can see the SoCs area. This is the where I was talking about, where you can have multiple different processors in one chip and one board. And the variance is also important for anything that uses the ARM secure functionality. So by default, you're using, if you have a chip, you have the two options, just the secure and non-secure. So that's what the NS is. And then having revision. So I do change these boards, when I need to. Hopefully these new releases shouldn't require a lot of updates. A lot of it had to do with COVID and all the crazy supply chain issues. But there are actually different formats for this revision. You can do like a semver, like a Git one, or you can do a letter, or you can do a number. I prefer the number, mostly just because it matches up with the board revisioning that I use here. Some people like using numbers for prototypes and then letters for production. I just keep it to numbers, keep it simple. So that name should look familiar. That's the name of the board. Vendor, that's me. And this is kind of just revealing the things I just touched on, but puts it all out there. It's easy to understand from a human point of view, and that's the file that kind of gets sucked in by Zephyr to actually know what's going on and what's available for you to use. You can see that that value, some values are actually put into that circuit Dojo. There's a new kconfig file, and that kconfig file is, I can actually pull it up on the side here so I can look at it while I allow boards. Kconfig. So these do exist. Actually, let me see if I can share my screen, because it's actually kind of handy. Oh, yeah, but Inception here. Oh, that's not. All right, back to this. But essentially, we have the config values that I mentioned before. They're just getting set here as defaults. You can actually put in other kconfig board specific things. So, for instance, I put a PMIC startup value that can be set as default, so it can load some startup code for the bootloader and for the application if you really want. But as mentioned, these other values, they're important, and they're part of the definition of your board. Like this will unlock and use kind of the underlying drivers and things in the system, but they're kind of getting turned on elsewhere rather than putting in them in the default configurations. They're actually getting called on in the, and I wish I took a snippet of that kconfig.circuitdojo_feather, because that actually has that configuration, and then it's selecting the SoC series. So it's kind of doing it in the kconfig file rather than the kind of like the default config file. So it's just things are getting moved around, so it's less redundant to some extent. So the nice part about this is, like, you can jump into a rabbit hole, and it might be prone with error. So one thing that the Zephyr devs did is they actually created a script that you can use to run on an old. So if you have an out of tree board definition, you can actually run a Python script that'll convert it and kind of put it in the place that you would like it to go into, and kind of match the new file structure. So you can see here, this is kind of what I did to run the conversion, and it's simply, I'm setting the board root, and I'm setting the name of the board, and setting the vendor name, and also the processor name, and also just the output file. So there's a bunch of stuff going on there, but the what resulted in that is just the board YAML file earlier, which is this guy. So that's what it's kind of turned into. It generated this board, got rid of some things, added some other things. pretty handy, and you don't have to think about it too much, which is really nice. So consider using that script if you have some out of tree board definitions. But this is what it did. It moved. So this is in the NRF 9160 Feather examples and drivers repository. So everything lived in boards, ARM, Circuit Dojo to now it's in boards, Circuit Dojo, and then the name of the board. The reason why, so currently in the Zephyr, vanilla Zephyr repo, it's in a Feather directory, but they can't coexist together. So I'll end up, it's kind of redundant. I'll have to rename them to some extent or rename that one. It'll be a PR that I'll have to push up to them. So everything will kind of exist together in harmony. But added all the modified files, and then let's see. Oh yeah, and then that's just the name of the processor, as I mentioned. It's redundant if you actually type out the name of the when you're invoking West build and you're including the name of the board. You'll be writing NRF 9161 twice, so that's just something to keep in mind. And did I include the usage of that? That's important. But the things that have changed, mostly everything else. So the pin control settings, the DTS files, the CMake list files. If you are using NTS, I will be including the partition management definition, because they do some dynamic partition generation on the NCS side for whatever reason. I haven't looked too deep into it, but it would be great if that just used the DTS files. But I think there's some other things that are important there. There's the TFM permission or partition for the newer chips, so that's just something to keep in mind. Here is the full kind of all the files that are included, including all the new ones that were created. It should look fairly familiar. It's going to be half as much if you're just using just a regular processor. Let's say NR52840. You're not going to have all these NS entries. So, man, I wish I could show you guys. Maybe we'll do that a little bit after some question and answers, because I do want to show some things, and maybe I can actually get this thing to show things correctly. On to Sysbuild. Make sure there's no other questions. Hey, Franz. Good to see you. Let's talk about Sysbuild. So Sysbuild allows you now. So this is something that was really cool that I enjoyed in NCS, was the fact that you could build your application, merge it with MCUboot, and flash it as one hex file to your device, and just like it magically worked. It did all the signing and all that other fun stuff. And it's like, okay, cool. Maybe someday vanilla Zephyr will have that, because for you guys, I'm sure you're very well aware, painfully aware, that the process for doing that same thing was more manual. So you had to build the application, you had to sign it, you had to build the MCUboot application and merge them together, and then you could kind of put them together and flash them. So this functionality actually allows you to do it automatically, which is really nice. It is configured. There's a bunch of different ways to configure it. There's actually a West command line entry. There's also some config files, so the sysbuild.conf and also the sysbuild folder. So we will dive into a little bit of that. In order to invoke it, so right now, in Zephyr 3.7, in NCS 2.7, I believe you can still invoke West, and it will not use Sysbuild. So right now, you do need to include the Sysbuild flag, or you need to enable it using West config. So that West config will basically say, hey, for every application, for every sample, when I'm invoking West, I want Sysbuild to be enabled by default. I elected to use the Zephyr tool, or the flag, that -- sysbuild flag in Zephyr tools, just because I'm trying to stay backwards compatible with everything else. So use whatever functionality you like to invoke Sysbuild. It's really personal preference. So now, in order to tell Sysbuild what to do or what other images you want, basically you can enable these images by including an entry in sysbuild.conf. Or you, as I mentioned, you'll need a Sysbuild folder, and that will allow you to kind of completely customize. So like it actually, if you include this folder and then you include the app name, it'll break at compile time saying you're missing a prj.conf. These are literally overriding everything that could be in that image. So if you put a MCUboot folder, it'll actually override the prj.conf in there. So not only do you have to probably copy that over, but then also provide any customization and edits. As far as I could tell, there's no easy way to add a board-specific overlay. So that's one thing that I was kind of taking advantage of with different boards is, for instance, NF9161 Feather has an onboard programmer. So it's like, I don't really need MCUboot in some cases. So I'd rather just turn it off and then turn it on for the NF9160. And the NF9160, I was using the config MCUboot bootloader equals yes, and it's slightly different now, and there's not really a good way to do that without adding the sysbuild folder and kind of going down the rabbit hole. But you guys will see what it looks like here. So in sysbuild.conf, this is actually turning on the bootloader. You can go to that link. I actually included some links in the description below. You can go to them and kind of see some of the information about enabling different images. There are other images that you could enable. We're not going to dive too much into that because it's kind of more of a high level review. There is actually a bunch of entries or configuration variables for MCUboot, and I think they're in the Zephyr documentation, not so much in the vanilla or the NCS documentation, not so much in the vanilla. I will find, if I can find that whole list, I will put that in the description below as well. I could not find it before the video started. So for those who are familiar with NCS, there is a child image entry, and it is no longer used. So as long as you're using Sysbuild and you're using the latest version of NCS, you don't have to. It's no longer used. So you're using the Sysbuild folder instead. And so for here, like for if you want to modify MCUboot, if you want to turn some things off, change some things with an overlay configuration, not board specific, you can add that to the sysbuild/mcuboot.conf. Here's a more complicated version, which I was kind of alluding to earlier, is like if you want to override the full thing, you can see that my sample entry under the Sysbuild folder, you just name it whatever. So you want to name it MCUboot, or if you have another image that you're handling, and you can see that like that prj.conf, you can add overlays and board specific overlays. So this is where, going back to the functionality that I was really enjoying, it was pretty simple to implement, mostly just because it was kind of more Nordic proprietary. Is whenever you turn on the bootloader, it just kind of did its thing. Well, this allows you full control over that image, over that Sysbuild image, and you can add board configuration overlays and DTS overlays. So if you have a situation where, okay, I want to add an MCUboot, but things are changing, I need to make some big changes for compatibility reasons, you have multiple boards, there you go. It gives you some options. One other thing that was kind of fiddly, and I haven't tried it yet, but they actually made some functionality added to debugging for multiple images. So previously with NCS, I personally could not get or figure out how to get debugging working when I had MCUboot installed on the device, because what it would do is it would jump to 0, and then it would run through MCUboot and then forward and jump to the application. The problem is when you're running the debugger, it's expecting to be in certain portions of flash, certain portions of memory, so it wouldn't line up. So removing MCUboot would allow debugging to work. Now, with West debug, you can actually indicate, hey, I want to debug MCUboot. I want to debug my application. And it's a really nice little added feature here. And that flag is the -- domain flag. So here is the invocation. So you can see West debug, your app name. In my case, I was using like my test app. So that would be -- domain test. And then the if you want to do MCUboot -- domain MCUboot, that'll start up the debug server, and that will allow you to connect. You could connect to it using the Cortex debug and VS Code or anything like that. So you can see like PyOCD GDB server running on port 3333, and you can roll with it, which is really great. So I know this is a lot of information in a short amount of time, but that was kind of the high-level overview of hardware model version 2. We ran over Sysbuild, multi-image builds in vanilla Zephyr, which is great because it was something that was kind of missing for a long time. And I can imagine some really cool things coming from this. One thing that I was really excited about previously with, this is probably far off, but one thing that was cool with Particle once upon a time when they were leveraging FreeRTOS is basically they created a system library and then they had application binary, and the application binary would basically call the library. They're living in two separate areas, and you could upgrade the application as long as it's the same version of the library. And upgrading it was a lot easier, a lot smaller. We're talking about a difference of 10 in terms of size. So applications in Zephyr on an NRF9161, when doing OTA, it's like 300 something kilobytes. And you can imagine, okay, I have an application that I could just the functionality, just the core functionality of that application. You can get that down to 30, 40. So it's a huge difference. But I know that's something further along, but it's cool to see that we're seeing some great improvements in the Zephyr ecosystem. Remember that you can really go deep and configure Sysbuild to do whatever you want to. You can update the configurations, the project configurations, the overlays, or you can just simply use an overlay that's the name of whatever image you have. It really depends on your situation, what you need to change. So, and debugging, which is awesome. Well, let me see if I can get this up and running here. Let's see if I have any questions. If you guys have any questions, shoot them in the chat. Let me go see if I can show this on my app. La, 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 la. If you haven't already subscribed to my email list, where can I point? You can go to jaredwolf.com, and I like to send out messages and updates before these live sessions occur. So, oh no. Well, that's no bueno. I just explained the whole thing, and you guys couldn't hear anything. Audio's gone. Sorry, guys. I'm gonna turn this down a little bit. It's kind of loud. But the basic thing I was just saying here is, let me just make sure. There we go. All right. The basic thing I was just saying here is that the entry here, the SOC NF9161 LACA, that was originally located in the default config files, so in here and in here. And basically this allows just board wide to set certain variables instead of kind of doing them in the default config entries. The other config I was just talking about was I'm actually selecting it or using it in this cmakelist.txt. This is completely optional. It's mostly for any customizations that you want, or you want to add some startup code. So in this case, I was just adding the startup.c, and I'm running some configuration here for the npm 1300, increasing the sysreg current limit. So by default, it's 100 milliamps, and just changing it to 500. Because anytime you use the radio, you're using a lot of current, and if you only have USB plugged in and no battery, it will actually cause all types of weird issues, modem issues, or the device will reset. So sorry about that. Trying to explain things, and I didn't even turn my microphone on. Great, wonderful. Let me see if you guys have any other questions. Merrick, using ESP32. Oh, actually, I didn't have any supply chain issues with the Nordic parts. It was all with the supporting parts on the board. So power supplies, load switches. What else was a big issue? I managed to keep enough of the accelerometers, but the accelerometers were hard to get. Let's just say that. I know ST had some issues with their supply chains over COVID. So this is awesome. There's a bunch of people here. Well, I'm really glad to see everybody here. I really appreciate you all being here. If you'd like to see more videos, more content, something specific, if you have questions, I love answering them. Please leave a message in the comments down below, and I will create a live session for you. Often, especially if things are overlaying, I'm spending a lot of time in code. It's usually something that I've tackled or I'm about to tackle. So I'd love to share more with you guys as I venture more into Zephyr land here. Let's see. I do have a question from Eric, if I can read it. How urgent do you think it is to make the shift? So right now, for me, it was more urgent because I wanted to make sure that all my devices supported the newer versions of Zephyr. I had some requests from customers that they wanted to upgrade, want to be able to use those boards. Ooh, I'll show you guys the name of the boards because that is a little bit different. I thought I had that in there. But it's really up to your use case. Sometimes people like living on older versions of Zephyr because they know all the idiosyncrasies, they know all the issues. There hasn't been a lot of, so when I upgraded, there hasn't been a lot of API changes, which has been great. It's more of kind of underlying, like the board changes and Sysbuild is kind of like underneath. It doesn't really, not a lot of application level changes. So it might be pretty smooth for you. If you have out of tree, what I would do is I just create a branch of your application and then update your West manifest to the Zephyr, the newer Zephyr version. Like for instance, this one is, I'm going to switch over here again. Hopefully I keep my audio. Where is my... So for instance, I just updated my manifest to version 2.7. And then what I did is I pulled all the dependencies, did a West update, and then I went through and updated the boards with that script. Also, this should work on older versions. So if you're using NCS 2.6, the functionality is there. It's just it wasn't like fully released yet. So they're kind of adding things in parallel. And now going forward, Sysbuild is the default, and the previous versions of NCS, for instance, are not, or the previous versions use a different system. New versions beyond NCS 2.7 will be using Sysbuild. So that's just something to keep in mind. Nordic had a bunch of good documentation. I'm going to add that too here as a note. Things to get after here. Nordic. They had some good notes on conversion from previous to Sysbuild, and I'll add those down below. And then finding the other Sysbuild variables might be useful for you guys as well, because there are some Sysbuild configuration that you can add in that configuration file that are additionally helpful for different use cases. So one thing I want to show you guys that I totally forgot to talk about is that the board name itself has changed. So instead of, so many of you are aware of, this is what it used to be for these Nordic boards. You know, you could have the Nordic NRF91 SDK, blah, blah, blah. It always kind of looked like this. So going back to, so now it is using these dashes. So I kind of mentioned before that this NRF9161 will be redundant, and that's just because it's the board name and because there's also NRF9160 out there. So for now, both of those definitions of updated board files with hardware, the hardware version Model 2 is in the 2.7 branch of NFED. So if you guys are curious, that as well. Link 2.7x branch. I'll add those after the video. I'll add a link to those guys. So, but that's something to keep in mind when you're building. If you don't turn on Sysbuild, I believe you can still use the old version of the board. Actually, I don't know if it'll work like that. Once you get to a certain version of Zephyr is expecting. So yeah, let me correct myself. Newer versions of Zephyr, you need the updated board name. You can't use the old one. Sysbuild has nothing to do with the board name. It has to do with the board model. So the hardware model version 2. So I keep hitting the wrong thing here. There we go. That's the screen I want it to be on, but I'm gonna get I gotta get that fixed. Let me see. Any other questions? Cool. Well, you guys are awesome. I think that's it for questions. But if you guys have more, you can throw them in the comments down below. And really appreciate you being here. And I'll see you on the next rendition of Zephyr 101. See ya.